Welcome back to the Deep Dive. We are diving into Tesla AI Day 2022.
Lots to unpack.
Yeah, we've got a whole stack of sources here,
Transcripts.
videos, all that good stuff. And we're going to break down what really matters.
Yeah, it was a whirlwind.
For sure.
Robots, self-driving updates.
Crazy.
Even a supercomputer just for AI.
Exactly. But we're not just going to recap the flashy demos.
Right.
We're going to help you understand why all this matters. Even if...
Especially you're not an engineer.
Right, we're focusing on the potential impact all this could have. I mean...
Huge implications.
From manufacturing to...
The future of work.
Future of work, yeah.
Okay, let's unpack it. Last year at AI Day, they teased Optimus, the Tesla bot.
Right.
It was literally just a person in a suit.
A dancer in a suit.
They unveiled actual working prototypes.
Yeah, and not just like standing around.
Right.
One of them walked on stage.
Untethered.
Totally untethered.
Which is just crazy how fast they're moving.
Yeah.
Like leveraging their expertise from vehicle design and applying it to this new field.
What's so interesting to me is they're already talking price point under $20,000.
I know. That's unheard of.
Unheard of for a humanoid robot.
For a humanoid robot.
Like most robots in this category are hundreds of thousands.
At least.
If not millions.
Yeah.
So that keeps them confined to research labs. But at $20,000,
right,
you could see businesses.
Of all sizes.
Yeah. Mom and pop shops. Using robots.
Okay, so say a small business owner is listening to this right now.
Yeah.
What are some practical examples of how they might actually use Optimus?
So think about tasks that are repetitive or dangerous for human workers.
Okay.
So maybe loading and unloading heavy boxes.
Makes sense.
Doing inventory in a warehouse.
Okay.
Even like assisting with tasks in a restaurant kitchen.
Interesting. And because Tesla is focused on mass production, the cost could come down even further over time.
Exactly. It's like what we saw with electric cars.
Yeah.
Early adopters paid a premium.
Totally. But as production scales, the price becomes accessible to a wider market.
So Optimus is way more than just a cool demo.
Right.
This could actually change the game.
For a lot of businesses.
Yeah.
Yeah, and we haven't even touched on the AI.
The AI that powers it.
That powers it.
Yeah, they said they adapted a lot of the autopilot software from their cars for Optimus.
Right.
The same software that's already navigating streets.
Identifying objects.
Is helping this robot understand its surroundings.
Yeah, it's a huge advantage for Tesla. They don't have to start from scratch.
Right.
They're leveraging what they've already learned from millions of miles of real-world driving data.
So how much modification did it take to make the autopilot software work for Optimus?
Surprisingly little from what they shared.
Okay.
The core computer vision networks, the ones that identify stop signs or pedestrians, were ported over pretty directly.
So the robot can already see and understand the world to some degree?
To some degree, yes.
Right.
And a key part of the training process involves simulation. So they're using virtual environments to teach Optimus how to move and interact with its surroundings.
Like a video game for robots.
Exactly. And this allows them to speed up development tremendously.
Why use simulation instead of just teaching it in the real world?
Well, for one thing, it's safer.
I was going to say, yeah.
You don't want a robot
breaking stuff,
bumping into things, or making mistakes that could damage itself or the environment.
Right.
Especially in the early stages.
Plus, in a simulation, they can run thousands of training scenarios
in parallel
at the same time.
Yeah, which would take forever in the real world.
Okay, let's talk about the actual design of Optimus.
Okay.
They mentioned reducing the robot's degrees of freedom.
Degrees of freedom.
For efficiency.
Right.
What does that even mean?
Degrees of freedom refer to the number of ways something can move.
Okay.
The human body has over 200.
Wow.
Which gives us incredible flexibility, but is also incredibly complex.
So they simplified Optimus.
They did, but in a very clever way. They focused on the essential movements needed to perform useful tasks.
Got it.
Optimus has 28 degrees of freedom.
Still a lot.
Which is enough to be versatile, but without unnecessary complexity.
They went deep on how they designed the actuators and joints. There was a whole segment about a 4-bar linkage in the knee.
Oh, yeah.
What was that all about?
That's a great example of their engineering ingenuity.
Okay.
So the 4-bar linkage is a mechanism that optimizes the force the knee can generate, making it more energy efficient.
So it's not just about building a robot that can move. It's about making it move gracefully and efficiently.
Precisely. They're applying the same principles they use in designing car suspension systems.
Interesting.
To create a robot that moves smoothly and conserves energy.
They even talked about reducing idle power consumption.
Yeah.
I guess even robots need to be energy conscious.
Absolutely. They emphasize that Optimus is designed to be instantly ready for work, unlike humans who need time to wake up and get going.
Very true. But speaking of humans, one of the biggest challenges in robotics is designing hands that can manipulate objects.
Right.
Did they cover that?
They did. They showed Optimus grasping a variety of objects.
Cool.
They emphasized that the hands need to be adaptable, able to handle different shapes and sizes.
But what about holding objects for a long time?
Blech.
Doesn't that drain the battery if the motors are constantly engaged?
Great question. They addressed that with a clever feature called a non-back drivable finger drive.
Okay.
Essentially, it's a clutch mechanism that allows Optimus to hold an object without the motor needing to constantly apply force.
So it's like how we can hold something in our hand without actively flexing our muscles all the time.
Exactly. It's a subtle detail, but it shows their attention to energy efficiency in every aspect of the robot's design.
Okay, so we've got this surprisingly affordable, energy-efficient robot that can see and manipulate objects.
Right.
What's next?
Well, let's shift gears and talk about what they revealed on the full self-driving front.
Full self-driving. They've been promising this for a while, but it seems like it's still in beta.
It is, but the beta program has expanded significantly.
Okay.
It's now in the hands of 160,000 customers compared to just 2,000 last year.
Wow, that's a huge jump.
Huge jump.
So does that mean it's almost ready for everyone?
It's hard to say for sure, but the progress is clear.
Good.
They talked about training 75,000 different neural network models in the past year alone.
75,000 models.
Oh, no.
That seems excessive. Why so many?
It just highlights the complexity of the challenge.
Okay.
They're trying to teach a car to navigate the real world, which is incredibly unpredictable.
Right.
So each model is trained on different data sets and designed to handle specific driving scenarios.
So it's like having an army of AI drivers.
Yeah.
Each with their own
little expertise.
Exactly.
And they're using all of this data to refine their algorithms and make the system more robust.
Okay, all this data must require some serious computing power. How are they managing that?
Well, that brings us to their next big reveal.
Okay.
They call it Dojo.
Dojo, is that like some kind of martial arts studio for robots?
No.
Okay.
It's their custom-built supercomputer designed specifically for AI training.
You mean they're not just using regular supercomputers?
Nope.
Why would they go through the trouble of building their own?
Because they need something even more powerful and specialized for the types of AI workloads they're running.
Okay, give me the details. What makes Dojo so special?
Well, for starters, they made some pretty radical design choices.
Like what?
Like rejecting DRAM as the primary storage medium.
Wait, DRAM isn't that like the standard memory used in most computers?
It is, but Tesla opted for SRAM instead.
SRAM, that's usually used for smaller, faster caches.
Within a processor, yeah.
Why would they use that for an entire supercomputer?
Because they prioritize speed and responsiveness over raw storage capacity.
Okay.
SRAM has much higher bandwidth and lower latency than DRAM.
Makes sense.
Which is crucial for training these massive AI models.
So they're sacrificing storage space for speed.
Yeah, it's like they're building a race car instead of a truck.
It's all about performance.
It's all about performance, and they didn't stop there.
What else?
They also made the unconventional decision to eliminate virtual memory and interrupts, which are standard features in most computers.
Wow, that's a bold move.
Yeah.
What's the reasoning behind that?
They want to squeeze every ounce of performance out of the system.
Okay.
By eliminating these features, they can reduce overhead and simplify the design.
Interesting.
Making it more efficient for AI training.
So Dojo is a supercomputer, unlike any other.
Pretty much.
But how did they even manage to build something so radical?
I know, right?
I mean, they must have faced some serious engineering challenges.
Yeah, absolutely. Scaling up a system like this is no easy feat.
What were some of the biggest hurdles?
Well, they had to figure out how to deliver enough power, keep everything cool,
Right.
and optimize data throughput to ensure the system runs at peak efficiency.
So they didn't just design a supercomputer. They had to rethink the entire infrastructure around it.
Exactly. They designed custom chips and interconnects to maximize performance.
Oh, wow.
And they had to develop entirely new software tools to manage this beast.
Okay, so we've covered Optimus the robot with the potential to disrupt industries, full self-driving, getting into more hands, and Dojo, this custom-built supercomputer that seems to defy convention. Where do we even go from here?
Well, let's take a step back and consider what all of this means in the bigger picture.
Right, because it's easy to get lost in the technical details and miss the forest for the trees.
Right.
What are the broader implications of all these advancements? What's the so what for our listeners? We've been talking about robots and self-driving cars and supercomputers, but what does it all actually mean for the average person?
Yeah, it's easy to get caught up in the excitement of new technology, but we got to think about the real world impact.
Totally. So let's bring it down to earth. Think about the basic building blocks of any economy.
Okay.
You got labor capital and productivity. So how do Optimus and full self-driving fit into all that?
Well, let's start with labor. Imagine a world where robots can handle a lot of the tasks that humans do now,
Okay.
like manufacturing, construction, even caregiving.
That would free up a ton of human labor,
It would.
but wouldn't it also lead to massive unemployment?
That's a big concern people have about automation.
For sure.
It's valid, but if we look back at history, technological advancements tend to create new jobs in industries that we couldn't have imagined before.
Like how the internet led to all these new jobs in e-commerce and social media.
Exactly. We can't predict the future perfectly, but we can learn from the past. The key is to adapt and focus on skills that are uniquely human, things that complement these new technologies.
So instead of robots taking our jobs, it's more about figuring out how to work alongside them.
That's the idea. Collaboration, not replacement. Now, let's talk about capital.
Capital as in money investments.
Yes, but also the physical assets and infrastructure that drive an economy, like factories, transportation networks, and even the tools we use to build things.
Yeah.
Optimus and full self-driving could make our use of capital far more efficient.
I'm not sure I'm getting the connection. Can you give me a real-world example?
Sure, imagine a factory that can operate 24/7 with robots handling a lot of the tasks.
So
That's a huge boost to productivity, and it means you can get more out of the same investment in buildings and equipment.
okay, I see what you're saying.
Yeah.
But what about the upfront cost of developing and implementing all this new tech? That's a barrier for a lot of businesses.
It is, but the cost of robotics is dropping rapidly. Tesla is aiming to sell Optimus for under $20,000, which is unheard of for a humanoid robot. As these technologies become more common, the cost will continue to fall.
So it's kind of like a snowball effect. Lower costs lead to wider adoption, which leads to even lower costs.
Exactly, and that brings us to productivity. AI and robotics can unlock huge gains in productivity across all sorts of industries.
How? So can you give me some concrete examples?
Think about all the tasks that are repetitive, time-consuming, or even dangerous for humans. Robots can do those things more efficiently, accurately, and tirelessly. This frees up humans to focus on higher-value tasks that require creativity, problem-solving, and emotional intelligence.
So it's not just about replacing human labor, it's about amplifying it. We're not being pushed out, we're being empowered to do more.
I love that way of putting it. And as productivity increases, so does economic output, which can lead to higher standards of living and greater overall prosperity.
This all sounds pretty optimistic. Are there any downsides or risks we should be thinking about?
Of course, any powerful technology has the potential for unintended consequences. We've already talked about job displacement, which is a real
Right.
concern.
Even if new jobs are created, there will be a transition period where some people might be left behind. What can we do about that?
We need to make sure there are strong safety nets and retraining programs to support workers who are impacted by these changes. We can't just leave people behind.
What about other potential downsides?
Well, we have to be mindful of the impact on the environment. Manufacturing robots and powering supercomputers requires a lot of energy and resources we need to develop these technologies in a sustainable way.
So it's not just about the technology itself, it's about how we develop and use it responsibly.
Exactly. It's a complex equation with a lot of moving parts.
Now let's bring it back to Tesla specifically.
Yeah.
One thing that impressed me was their emphasis on real-world data and applications.
Yes, they're not building theoretical AI systems in a vacuum. They're focused on solving practical problems, whether it's making driving safer or developing more efficient manufacturing processes.
It seems like they have a very pragmatic approach.
They do, and it's evident in their focus on data collection and analysis. Remember, all those neural networks, they're training on massive amounts of real-world driving data.
Yeah, they mentioned 75,000 models. It seems like overkill, but they're really committed to making sure their AI learns from real-world experiences.
Right. They're carefully selecting and refining their data sets to make sure their AI models learn the right things.
It's like they're building a digital replica of the real world, capturing all the nuances and complexities.
It's a great analogy. They understand that to build AI that can function safely and effectively in the real world, it needs to be trained on data that reflects the messiness and unpredictability of real life.
And they're not just relying on data from their cars, they're also using simulation to generate synthetic data and test out new algorithms in a safe environment.
Exactly. Simulation is like a virtual playground for AI development. They can try out different approaches and experiment without any risk.
It's like a giant sandbox for AI.
I like that. And by combining real-world data with simulation, they're creating a powerful feedback loop that drives continuous improvement.
So this data-driven approach seems to be key for them, not just for full self-driving, but also for Optimus and Dojo.
Yeah, it's a common thread. You see it in everything they do. They're investing heavily in the infrastructure and resources needed to collect, process, and learn from massive amounts of data.
It's clear that Tesla is playing the long game here. They're building for the future, and they're not afraid to take risks and challenge conventional thinking.
Absolutely. Their decision to build their own supercomputer Dojo is a perfect example. It's a huge undertaking, but they're betting that it'll give them a significant advantage in the AI race.
Dojo is definitely a game changer, but it also raises some interesting questions about the future of AI hardware and infrastructure.
For sure, as AI models become more complex and data intensive, the demand for specialized hardware will only grow.
So we might see more companies following Tesla's lead and building their own custom AI chips and supercomputers.
It's definitely possible it could lead to a more fragmented and specialized AI landscape, which could be both exciting and challenging.
Exciting because it could lead to more innovation and competition, but challenging because it could make it harder for different systems to talk to each other.
Exactly. Interoperability will be key as the AI ecosystem keeps evolving.
It's a lot to think about. So we've gone deep on the tech, explored the potential economic impact, and even touched on some of the challenges and risks. What does it all mean for our listeners? What's the takeaway for someone who's not an engineer or a tech expert? Okay, so we've covered a lot of ground in this deep dive. Robots, self-driving cars, supercomputers. It's clear that Tesla is really pushing the boundaries of what's possible with AI.
Yeah, but I think it's helpful to zoom out for a second and think about what these advancements could actually mean for everyday life, for people who aren't super into tech.
Or let's get out of the theoretical and talk about some real-world applications.
Okay, so picture this. You're commuting to work.
Okay.
But instead of being struck behind the wheel, your car is driving itself so you can relax, catch up on emails, maybe even take a nap.
That's the dream, right? The promise of full self-driving. And it feels like we're getting closer and closer.
Absolutely. And it's not just about convenience either.
Right.
It could make our roads much safer by reducing human error, which is, a major factor in most accidents.
Yeah, fewer accidents, less traffic congestion, more free time. It's like a win-win all around.
Exactly. Now let's talk about Optimus for a second.
Okay.
Imagine having a robot that could help you with chores around the house.
Okay.
Or maybe assist an elderly family member with daily tasks.
It sounds so futuristic.
It does, but like we've discussed, Tesla's making it happen.
Yeah.
And as the cost of robotics comes down, these sorts of applications could become a lot more common.
It's mind-blowing to think about how this tech could change the way we live and interact with the world.
It really is, but it also raises some interesting questions about the role of humans in a future where AI is so prevalent.
Right, like if robots are taking care of all these tasks, what will we do with all our free time?
That's the big question, right?
Yeah.
It's a huge opportunity to rethink our priorities and focus on things that are uniquely human, things that bring us joy and fulfillment.
Maybe we'll see a resurgence in the arts, or people spending more time connecting with each other, building stronger communities.
It's a chance to redefine what it means to be human in a world where technology is constantly evolving.
And to make sure we're using technology to make our lives better, not worse.
Exactly. It's a responsibility we all share.
So as we wrap up this deep dive into Tesla AI Day 2022, what's your final takeaway? What should our listeners be thinking about?
For me, it's all about embracing the possibilities while also acknowledging the potential challenges. We're entering uncharted territory here. And it's up to all of us to shape the future of AI in a way that benefits humanity.
It's an exciting thought, and maybe a little daunting too.
It is, but one thing's for sure, it's going to be fascinating to see how it all plays out.
Well said. And to our listeners, we hope this deep dive has given you a better understanding of what's happening at the forefront of AI and what it all might mean for you. Until next time, keep exploring.